combination sum given an array of distinct integers candidates and target integer target. Return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combination in any order. The same number may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. The test cases are generated in such that the number of unique combinations that sum up to target are less than 150 combinations for the given input. So in this example, we have candidates list, which is this, and target, and these are the two numbers. The three numbers, two sets of numbers, and in this list we have these three numbers that add up to 7, and in this case we have 7 adding up to 7. So in this example we have we have 8 as our target, and this is our candidate, and these three sets of numbers are the ones that add up to 8. And this example, we have candidate and target 1, candidate 2, target 1, so we don't have a match for that, so we have an empty list. So this is a backtracking problem. We'll we will solve this recursively. So let's make our recursive function. Let's call it backtrack, and then our start, and then our target and our path. So now let's make our base cases. Let's call this match. So if target is equals to 0, if target is equals to 0, let's make our result a variable here. Let's call result dot append a path dot copy method in Python. So now let's move out that function and make our result as a list equals to list. In this case, it's an empty result here. So, and let's also make our backtrack. Let's call it inside our combination. Let's call it a backtrack, and then put our starting at index 0, and then our target will be the change, and our path will also be the list inside the list. So let's call it, let's make it path, an empty list, and then return result. So these are the results here. So now let's get back to this. So return in case to stop the call, and then if target is less than 0, if negative, then terminate. Oops. Return. So now let's move on to our loop. So for I in the range of from start will be, in this case we're starting from 0 to 0 to hold on, 0 to the len of candidates. Okay, now we have the len of candidates. So for I in the len of candidates, so let's make a path. Let's append it. Let's append our I value to the path. So path dot append candidates I value. So now let's call on our backtrack, recursively call on a backtrack I, then candidates minus target minus candidate target minus candidate I, path. So this will make sure that these correspond. So this will be our new target value, whichever we get from this. This should be I. And then, so, target appended, and then candidate the I. And then let's pop it once we're able to path that up. So basically, we're going to take this number here and subtract it from, since our target will start with 7, subtract it, and then our new target will be after adding the 2 to the list, this list over here, representing here, and then do it again, add another 2. So now after 2 minus 7 would be 2. No, 2 minus 7 is 5, and then add another 2, 2, and then add the 2 again here again. 2 minus 7 again would be hold on. 2 minus 7 would be 2 minus 7. No, 2 minus 5. I meant 2 minus 5 would be 3. So will be 3. And then we take another 2 here, and then minus it by 2. Minus it by again 2. That would be so 2 minus 3 would be now be 1, and then take another 2 again. 2 minus, after adding it here, will be -1. So -1 will miss this function. Then we have to pop it, the 2 out of this list after adding it, and then again, and then we move on to the next I value, which will be 3, and so on and so on. It's a long list. Let's see if this works. If there's an error that needs to be fixed. Alright, and it works, yes. So So basically, this is a lengthy way to do it. It's like the worst case. Hold on. The worst time complexity. Time complexity is um, 2 of n. Hold on. Square 2 n 2 to the n. And the time complexity of this is no, space complexity. Space worst case. Time complexity is O of t times so t will be times different combinations in the turn. So different combinations. Let's call it C. It doesn't matter, but so our time complexity is 2 of n in the worst case. So this could take like a long time. So for example, in this case, we have to keep going, go again, keep trying, checking, going back and forth to make sure that we have one that's equals to 0. So and then we recursively call these and then add to list and then populate out if uh, once we get either one of these calls negative, or if you have a matching or negative value. So that's it for this one. Let's submit it to see if it works. And it's been able to work efficiently, but this problem takes a lot of time and space.